everyone, how you doing today? Happy April. It's April 1st, and we are finishing up area of irregular figures, which is going to be a 2-day lesson. So you're going to work on questions 1 through 5 today and submit one question. And then tomorrow you're going to work on questions 6 through 9 and submit a different question. So today I'm only going to work up through going through the example page, and then the next 5 questions, with the exception of the question that you'll submit through Google Forms. All right, what's nice about today's lesson is it really just kind of takes everything we've been talking about for the last week and a half and puts it together into one lesson. So again, we're talking about figures that don't have a set formula because they're not known polygons, right? So if they do not have a set formula, we're going to dissect them, divide them, decompose them, basically break them up into figures that we are familiar with, like triangles, rectangles, squares, so on and so forth. So basically what you're going to do is follow the same steps we've been doing for a while. Section up that shape into rectangles and or triangles, maybe some squares, then find the area of each polygon and then add those areas together. Now that's assuming that it's not an area of a shaded region question, which that would be a little different. Okay, so let's take a look at the first two examples, A and B. So we'll work on example A first, and then move on to example B. So example A, now you could look at this and say, oh, it's a trapezoid. Okay, so I could do the area of a trapezoid, or if we want to just focus on working through dissection and breaking this up, we broke this up into this triangle here, this triangle here, and then take a look what we have down here. We now have triangle A, B, and C. Now, I label triangles A and B the same, A, B, because this is an isosceles trapezoid. I know this because of the tick marks. And that means then if this rectangle has a base of 18, on its opposite side, this base is also 18. Now, the whole trapezoid, this base here is 30. So I take the difference of these two pieces, 30 and 18, and I end up with 12. 12 is what's left over to split between this base of this triangle and this base over here. So half of 12 is 6, so each base of the triangles are 6. So I have everything I need to find the area of triangles A and B, right? My base of 6 and my height of 8, so base times height divided by 2, base times height divided by 2. Here is our result, 24 square centimeters for both. Then for C, it's just a rectangle. So we have our base at 18 and our height at 8. So 18 times 8 is 144. Add together all 3 polygons, and we have a total area of 192 square centimeters. Okay, so pretty straightforward. We've done that numerous times before. For example B, looks like we have this here. And I know that you guys have basically the answer key right underneath this, but take a look what we have here, right? We have a triangle and a square. So if you just ask yourself, well, what do I know? How do I know this is a square? I know it's a square because of this tick mark, right? This tick mark means that this length and this length are equal. So if this is 12, so is this. Well, if this is 12 and this is 12, that means that all 4 sides must be 12. So right off the bat, I know, all right, well, that means that this is 12 here, and this is 12 here. So now I have everything I need. Area of a square is base times height, and I have the base and height. They're both 12. And then for my triangle, the base is 12 and the height is 7. So I have all the information I need. So let's take a look at how we decompose this with our formulas. So area of a triangle, base times height divided by 2. So we have our 12 and our 7, which you'll see over here. 12 times 7 divided by 2, which gives us 42. Area of the square is 12 times 12, which is 144. Add it together, and we have a total of 186 square feet. And that's that. All right. So the remaining questions that we're going to go through today just deal with drawing in some auxiliary lines and finding the areas of those polygons. Now, I did these based on how I see the picture. Remember, there are different options based on how you see it. So just for example, for question 1, I chose to continue right here and draw an auxiliary line. You may say, well, I don't see it that way. I see it drawing an auxiliary line this way and having this as one rectangle and this as another. do what you see fit, right? Here's my work for this drawing, but at the end of the day, no matter how you draw your auxiliary line, the area should be the same. All right, so just take a look quickly. I draw up my auxiliary line. That means that this side and this side are your equal sides, both at 1.6. So for A, it's a rectangle, base times height, base at 1.6, height at 4.6. So right here, my total area for rectangle A is 7.36. Then for rectangle B, it's nice because they tell me that this is 6.4 and this is 2.3. So 6.4 times 2.3, 14.72. Add those up and we're left with 22.08 square meters. All right, so that's the first one. Now for number 2, I'm going to ask you to submit this on Google Form, right? So you decide how you want to break this up. I maybe will give you 2 suggestions. You can maybe just draw an auxiliary line here and here. Or maybe you'd like to cut it up and draw an auxiliary line here and here. Okay. So regardless of what you're choosing, remember, your answer should be the same at the end of the day. When you submit through Google Forms, I will have the answer for you, so you'll be able to check your work. All right, but let's move on to number 3. So for 3, we have it looks like this staircase here. To find the area, I cut them up into 3 rectangles. So I'm using base times height. So for rectangle 1, I had my base of 4.3, height of 9.6. So that was pretty straightforward. I get 41.28. For rectangle 2, I have a base of 4.3, and now the height is this here. So if you remember what we said, when you're dealing with height, what you want to think about is if this is the height from here to here, right? It's a vertical line. And for that height, I have to account for all the other vertical lines that I have where I have some units. So I go across, I'm like, okay, nothing. Oh, and then I hit from here to here is 3.2. So take that into account. Oh, and from here to here is 3.2. So that height from here to here is actually the sum of 3.2 and 3.2, which is 6.4. That's how we got the 6.4. Okay, so for that second rectangle, we have 4.3, excuse me, times 6.4, and we get 27.52. And then finally, for the last one, rectangle 3, we have a base of 4.3 and a height of 3.2, 13.76. Add together those 3 areas, and we have a total of 82.56 square meters. All right. It might be helpful, like I'm doing highlighting in different colors. Maybe you want to grab a highlighter and highlight over different dimensions. It's really up to you. All right. Then move on to number 4. So number 4 was interesting because it asks for both area and perimeter. So we'll do with area first. So again, when I took a look at this, I decided to draw in my auxiliary line across here and down here. Interesting choice, but it's just, I like to use the numbers and to help me guide. Like if I drew it across here, it makes this first rectangle easy because here's my base and my height. So rectangle 1 is 12 by 2, so that's 24 inches, square inches, excuse me. And then rectangle 2, here's my base, and now I know this is 6 because this whole base, or this whole side is 12. This piece is 6, so what's left over is here, which is 6. And then go this way. Now this height, I don't know. I know the whole thing is 16 inches. I know from here to here is 2 because this dimension is 2. So if I do 16 minus 2, then from here to here, what's left over is 14. So this has a height of 14 and a base of 6. So I have 6 times 14, which is 84. And then last but not least, for rectangle 3, I take a look and I'm like, all right, well, I drew my auxiliary line. My height is 7. And if I go across my base, well, remember, this is a horizontal measurement. The whole side here is 16 inches. And from here to here, I found was 6 because it's part of that green rectangle. So 16 minus 6 gives me what's left over at 10. So I know that this base is 10. So 10 times 7 is 70. Add together all three, and we have a total area of 178 square inches. Okay, so far not bad. Now for this one, we also had to find the perimeter. So if you really look at this, it's quite nice, right? We have this whole side is 16. This whole side is 12. This piece is 2. This piece is 6. This piece was missing, right? But I know from here to here is 14. And then from here to here is 7. So if I do 14 minus 7, this is then 7. We found this to be 10. This was told to be 7. And then this is 16. So our perimeter is quite simple. There it is. And I kind of redrew everything so you could see the dimensions. So add up all those sides, and we have a total of 76 inches. Remember, it's perimeter one-dimensional, so it's just inches, not inches squared. Okay. And then finally we had number 5. So 5 is we have a pool, and then they want a 6-foot deck to surround the pool. So this is kind of like an area of the shaded region, but it's almost backwards because the shaded region is the pool. You want the area of the decking, which is technically the unshaded part. But it's the same idea as area of the shaded region. We're going to find the area of the big shape and then take out the area of the pool, and then we'll be left with the area of the decking. So the big shape is a rectangle, right? We know that this is 12, right? This is 6, and then over here would also be 6. So the whole side is 24 because it's 6 plus 12 plus another 6, okay? And then across, we have at 32, and same thing. We have 20 plus 6 and 6 is 32. So the area of the big rectangle is going to be 32 times 24. So here's our 32. Hold on one second. Times 24. And that gives us 768 feet squared. And then area of the pool, I'll be right with you, hold on, let me finish this. And then the area of the pool is going to be 20 times 12, which is 240 square feet.
If I'm upstairs,
okay.
is that okay if I
put
games on?
Oh, hold on one second. All right, and then the area of the deck is just going to be the area of the big figure minus the area of the pool. So 768 minus 240, which gives us a total of 528 square feet of decking. And that's your final answer. Sorry about that little disruption. My daughter had come down from upstairs. Okay, so these were your 4 questions that we did together, plus the 1 question that I'm going to ask, number 2, you submit on Google Form. All right, everyone, see you tomorrow. Take care.